Okay, let's start, everybody. So, okay. Should give a couple of seconds,
Okay.
otherwise I will keep taking care that you stay a little bit longer on stage, so that's fine.
Subtitles.
Okay, everybody, welcome for our next session. Debug like a pro, ephemeral container with Wolfi Linux image. I hope I did it right.
I'll step over here.
Our speakers are Chet and Laura. And yeah.
Natalie.
Huh?
Natalie.
Natalie.
No worries, yeah.
Oh, that's my fault. Okay, Natalie and Chet. And yeah, welcome.
Hey, thank you all for being here. I'm Natalie.
I'm Chad.
And this is our talk. It's called Debug Like a Pro, Ephemeral Containers and Wolfi Linux in Action. And we're going to be discussing today a lot about image security, supply chain security, and how you can have fast, lightweight builds with distroless, zero CVE, and or minimal container images. So let's get started. So we wanted to look into a few of the biggest pain points that people see when they're debugging Kubernetes environments. And first and foremost, complex dependency chains. These can be a huge pain because you have dependencies, and your dependencies might have dependencies, which might have dependencies, and a vulnerability in a dependency further up the supply chain can have major implications for your whole application. We also see bloated images. Like, for example, maybe you're choosing a base image that has a lot of unnecessary files that you don't need, and that makes it bigger, slower to build, slower to deploy, as well as trickier to debug just because you have a lot more going on. We see tracking updates because we know that one of the best solutions to having secure software is keeping things up to date. And that can be a pain when you have hundreds upon hundreds of packages, as well as just making sure that you have the same configurations, which leads us into our next point, inconsistent dependencies. Because perhaps you have staging, you have dev environments, you have QA, you have UAT, and you start to see something like environment configuration drift, and that can be really difficult when it comes to seeing if your software will perform the same way across different environments, but it's also a pain dealing with keeping everything there up to date. So in our talk, we distilled it into 6 main things, because we are talking about debugging, how you can debug like a pro, but we also wanted to talk about other things you can do to kind of get ahead of the problem, because we're not just talking about debugging, we want to make debugging easier, so we're going to take these steps, such as reducing noise, which is just making sure that anything in your images is necessary. It should be there. Going distroless, which is the great answer to a multi-stage build, having the very last stage of your image be distroless, having as few moving parts as possible, just your necessary files and your executable. Vulnerability scanners, just making sure that you are staying up to date, you're doing repeated regular scans on your application, your packages, and understanding what's changing, what's being uncovered, what's getting introduced day by day, as well as image building, just making sure that you have multi-stage builds, making sure that the last stage of your image is secure to reduce the number and the potential for attack vectors. Supply chain security as a whole, because you don't want to have complex dependency chains that can be very overwhelming to remediate once something inevitably does get introduced. And then just talking about debugging as a whole, like how you can use distroless images to get into that. And well, first and foremost, one of the easiest ways you can get ahead of your debugging can be reducing noise. And by noise, we mean packages, dependencies, anything in your images that aren't serving a very specific or necessary purpose. They're just there, and maybe that's coming with your bloated base image. So where possible, reduce unnecessary dependencies. And that's not just to make your image more secure, but it's also just to give you less administrative fatigue going through, sifting through all the things you have going on, because yeah, the more dependencies, the harder it is to get through the noise.
Yeah, I think we're all guilty of using either a Ubuntu base image or Alpine. Just to show of hands, how many people are using those for their debugging containers? So yeah. That's some of the things that we're talking about in terms of reducing the dependencies and all the unnecessary binaries and libraries that we don't need for our application to run.
Right, exactly. And like something like Ubuntu or Debian might seem kind of, small when you look at it from a size perspective, but what really matters is the packages themselves and the quality of the packages. Also, of course, time to build. This might not matter so much on the smaller scale, like image by image, container by container, but this starts to add up. It's very not the greatest answer to cloud costs. So when you have stuff that shouldn't be there, you're paying for it, and you're multiplying that every single time you build, deploy, run your image. And also, it takes longer, which can matter when you have a complex, complicated microservice application. And then, of course, scanning results, because if you're running frequent scans, as you should be, you want to make that as painless as possible. But if you have dozens upon dozens of false positives, false negatives that show up on a day-to-day basis, it's probably going to, make you a little numb to the results. And when the results do matter, it's going to be harder to sift through and find out what is actually critical.
Becomes white noise after a while, for sure. Yeah. So I just wanted to point out why we use distroless images. It may be obvious, but the biggest thing, in my opinion, is that over 60 to 100 new vulnerabilities get introduced on a daily basis. So this is kind of a chart of that throughout 2024. And we're trying to catch our vulnerabilities as close to 0 day as possible. But at the end of the day, it makes it a lot harder to do so when you have so many coming out on a daily basis. So it's a matter of not only updating your vulnerability database, but it's just staying on top of this becomes really hard. So distroless becomes more of a selling point because you're using distroless, which ideally contains less vulnerabilities. I created this nice little demo here that perhaps you'd want to perform on your own later today. But this kind of proves my point in that we take two images, one minimal, such as this minimal Docker file here, starting with Alpine 3.18 and adding curl to it, versus the large Docker file, which I am definitely guilty of this, using Ubuntu 20.04 as our base image, and then adding all the necessary tools that I need to debug my environment, to test my environment, to make sure that the networking, storage, etc. is accurate and running as expected. So this is very common to see, and as a result, we see a difference when we run our Trivy scan reports, right? So here's the minimal scan report on that Alpine image, which contains two vulnerabilities and one vulnerability, one CVE, as you can see, versus the large, which contains a lot more. So you have 1,016. And so this is kind of an example of a bloated image, and why we're trying to move towards distroless to not have to take action on all these vulnerabilities, but also something that we have to keep in mind as we try to minimize our footprint and minimize the potential for security risk.
Yeah, and you might recognize that those packages themselves that Chad used in the bloated images, they themselves aren't necessarily notoriously harmful. They're probably things that we're all using in our applications day to day. It's nothing terrible, but when they add up like that, there is another answer. I guess we'll talk about this a little bit later, but how you can bake them into an earlier stage.
Yeah, and those vulnerabilities don't do nothing but increase, right? So it's not going to go down as more and more vulnerabilities get detected each day. Another case for distroless is making it easier to deploy distroless to your environments. I have a little demo for you here as well in video form. So we'll look at a Docker image that utilizes, I think, what's best utilizes distroless, in that we're using the same Docker file to deploy to two different environments. So if this is a multi-stage build. So in the first stage, we're building our Go application. Second stage, we're using this to deploy to our production environment. As you notice, the as production at the end of the from line. And then in stage 3, we're building a different version of our image that we're going to use to debug. So as we go through this building process, we can, and obviously this would be built into your CI/CD pipeline, but for the sake of the argument here, and for demonstration purposes, we run the Docker build command with the target, and then targeting that production, which is that step 2 that I showed you in the Docker file. Once we go through that, we can push that to our registry, which happens to be, for this demo, in a local registry. And then we are building our debug version, so kind of in the middle of the screen. Sorry for all the scrolling text, but we're running our debug version. Again, using that target to target that 3rd step in our multi-stage build, or the 3rd stage. And then we see we have 2 different versions, 2 different images that we're going to deploy to production now, or deploy to our environments. So one for our production and one for our development environment. And at the end of the day, what this means is that we can get a shell to our debug version of our app and be able to debug our production, being that we are running this in the same namespace and being able to run our, at least networking test in this case, as far as using curl. And then this allows us to use the curl or whatever it is, wget or netcat or whatever the debugging tool of your choice for our debugging environments, and then we can deploy a different version to our production environments, minimizing our footprint in our most vulnerable spaces. Moving on, this is another example of a multi-stage build. So we can, build our binary, and I understand, by the way, that not all applications can be built to a single binary. So this is just for demonstration purposes here, but when we can, we should be using multi-stage builds, and that when we utilize our first stage of our build, it's building our application using the Golang 1.20 Alpine, but in the second stage, we can not have to use the entire Golang library and build from scratch, only using the essential binaries and libraries to deploy to our production environment.
So on that note, we wanted to talk a little bit about Wolfi Linux, and Wolfi is one of ChainGuard's images. It's actually what they use as the base image for all the ChainGuard images, which is great. So if you've used a ChainGuard image, you by default have used Wolfi Linux. And it's designed first and foremost to be run in containers. It's an undistro, and it has the base version of it. It has no built-in kernel. The dev version does, but the base version only has any necessary packages, dependencies, for its runtime itself. And it's designed on a zero trust model. It's security first. It has very few, 0 CVEs, and it's often, like as we saw before, it would be a great option to use as a secure base image for the last stage of your multi-stage build. It has the capability to generate an SBOM, and a nice thing about it is all the packages are completely granular. They're all compiled at source, and that means you can remove them as needed, and removing one won't impact the supply chain because they're all on the same level. They're even with each other. So that will not impact your application.
And just a disclaimer, we don't work for ChainGuard. We're just a fan of their work. And hopefully ChainGuard folks here in the audience are not, judging us too hard.
Absolutely. Yeah, so we can see here that we have 4 common base images, 2 of which are ChainGuard images, and 2 of which might be common ones that you're using in your containers. Like, for example, Ubuntu, like as we saw earlier, so many of us are using that as our go-to base image. And at first glance, it's not terrible. Like, in the grand scheme of things, it's pretty minimal at just under 80 megabytes, and it builds quickly enough 4.6 seconds. But as you do see, it does have 97 packages, which the package number itself isn't necessarily as important as the number of CVEs, because you can have very secure packages, particularly granular packages. But when we compare it to something like Wolfi, we see that Wolfi, of course, is like bring your own dependencies, bring your own packages and tools, and it also clocks in at just like a fraction of the size, takes half the build time, and has not only fewer packages, of course, because it only has the necessary packages. And by the way, this is the base Wolfi. If the Wolfi dev has many more packages, but once you bring that to production, you just cut off the dev image tag. But it also, oh yes, totally. And yeah, zero CVEs. But you see, like, if we want more of an apples to apples comparison, we might look at something like Nginx and ChainGuard's Nginx image. When we see ChainGuard's, it's functionally equivalent, but it's a tenth the size. It's much faster to spin up, and it not only has fewer packages, but it has 0 dependencies, where Nginx, out of everything on our list, has the most at 87. And as Chad said earlier, that number is only going to go up as more dependencies get discovered, come out day by day.
Yeah, so as Natalie mentioned, we can use our ChainGuard images as the base for our applications that we're running in production, but also we can use Wolfi images for our debug images. And the thing that I want to point out here is all ChainGuard images come with the kind of latest, or the kind of the default tag for the images, and also we have the latest -dev. The latest -dev usually contains, as the slide alludes to, some additional software packages, comes with a shell, and stuff that you use to do more of your debugging. So just wanted to point out there that not only are these Wolfi images 0 CVEs and minimal, but also can be used in multiple use cases. So I could see us using Wolfi across the board and deploying, like I showed you in that demo, deploying to our dev environment, deploying to our production, using our multi-stage builds. So that way we're using Wolfi and using our ChainGuard images across the board. We're not having to utilize different versions of either the base images or the debug containers that we're using in our environments. We can use the most secure option as possible, just by default.
Yeah, absolutely. So I saw this comic initially during the XCD vulnerability, which, if I remember correctly, that happened on a Sunday, and it was something that we were talking about at work. And how many of you were in some way impacted by that vulnerability itself? That's probably almost half the room. Yeah, so that was a big one. And we can see, like in this comic here, we have when something gets introduced further up the dependency chain, further up the supply chain, it has major consequences for your application as a whole, and can be such a pain to remediate. And this is why we care so much about software supply chain security. And what you can do here is, the best way to stay ahead of your security is just keeping track of your SBOMs, your dependencies, your packages. And this is something that you can pretty easily generate with either a vulnerability scanner, or Wolfi itself can provide you with this. And it's not just for being aware of current and upcoming vulnerabilities, but it's also just making sure that you can kind of audit what you're actually using. Chad brought up a good point about being able to explain every single thing in your SBOM
Yeah, so when you're going through a security audit, or maybe you work for a government or a government contractor, you're going through either RMF or the MITRE framework. The idea is that you're trying to slim everything down to make sure that you can have the authority to operate, or be able to deploy your environments to whatever impact level. So that's always a concern when you're talking about having to kind of prove the things that you're using in your environments. So
Yeah, absolutely. So just making sure that everything there does have a purpose. Maybe you don't have dependencies that are redundant with other dependencies, and you can cut down, slim out wherever possible, and reduce the chances of something going wrong, and the terrible inevitability of something going wrong that you don't even need. Well, I guess it's worse when you do actually need it. You can't just get rid of it. But also just staying current with vulnerabilities. And this is something that we talked a little bit about earlier, but it's kind of difficult to do on a human level because we have like average of 100 being introduced every single day. So setting up like automated checks, cross-referencing your SBOM with a vulnerability database like cve.org, and then for absolutely making sure that you're keeping them as updated as possible. And then here, just controlling the number of dependencies, just understanding them, and wherever possible, finding good, secure packages that don't have complex supply chains, because those are going to be a lot easier to debug. And that might be something like, for example, like Wolfi does a great job of doing that, is everything is very easily removable and doesn't have a complex chain.
I like this. I'm just going to say I like this graphic, by the way, because I've normally seen it in the context of like that one. It says, yeah, one random person in Nebraska, like being in the context of open source, where there's always this one person who's like, maintaining the entire project from their basement in Nebraska. But yeah, this has multiple use cases, right? Because we're saying here that one thing at the bottom that the arrow is pointing to is that one vulnerability that you least expected and least wanted in your environment, and now you have to get rid of it. So,
yes, absolutely. And then just, of course, vulnerability scanners, always a great practice to have. Like we've used Aquatrivi for this presentation, but there are other great ones. And we learned a little bit earlier today just about cross-referencing, because they might not always give the same results. They might not give consistent CVEs, and you want to test that, and you want to make sure that you're confident in what they actually are telling you. And then, of course, just setting up checks with a vulnerability database, because that is a lot to work through if you're doing that day to day. But then once you're incorporating something like vulnerability scanning like into your frequent workflows, you're able to better audit and see what doesn't serve a purpose. So your reports, ideally over time, they get shorter because you're weeding out what doesn't make sense, and which can cause a lot of administrative fatigue if you're looking at 1,000 alerts, none of which matter necessarily. And we also were thinking about other great ways to incorporate different levels of vulnerability scanning. So for example, false positives can be a pain. So if you have context-aware code scanning, you're looking at perhaps a part of a package that might not impact your app. So maybe you ignore that. And you had a specific example of that.
Yeah, so I always use the example of backporting SSH. So the security scanner will almost always detect that as a vulnerability. That's an example of a false positive. It doesn't actually represent a true vulnerability. And then the other way around, right? It's like, who wants to have this big long report that contains things that you don't really need to take action on? So it's just a matter of, and also just not detecting the vulnerability at all, right? Like if you don't keep your scanners up to date, you could miss a lot of vulnerabilities and put your environments at risk.
Yeah, absolutely. And then also just making sure that you're, with reports this long and this dense, it can be really helpful to set a threshold, because vulnerabilities have severity levels. So maybe filtering out low vulnerabilities or things that you don't necessarily plan on fixing and are just going to be in there. And the shorter your reports are, probably the more likely you are to actually sift through and take things as seriously as they merit.
Right. Yeah. You want to have a container scanner that's configurable for sure. So yeah, just to zoom out, and Eric is going to talk to this in the next presentation. So I don't want to steal his thunder too much, but debugging tools. It would be remiss if we didn't mention, how to debug like a pro. So some pro tips for debugging. Using kubectl debug is kind of the obvious choice, I suppose. So kubectl debug inserts a container in the same context as your main container. within the same pod. And the benefit to that is that you're sharing the same network namespace and the same storage context, so you can get at the same level as your main application and do proper debugging. And then when you exit out of that debug session, your container is terminated. So that's also a way to not have these kind of long-standing debug containers just running constantly in the background in your environment. And then using cdebug, and I watched a really good video by from our folks at ChainGuard again, showing the differences there between using kubectl and cdebug, being that you can insert certain permission levels so that you can act as root when you're trying to view the file system of your main application, et cetera. So running that in the correct security context is also a good one. Adrian has a good video on that, so check that out on YouTube on the ChainGuard channel.
Absolutely. So at the end of the day, I guess we talked a lot, not just about debugging, but staying ahead of your security. And we figured out that one of the biggest takeaways here is just reducing noise wherever possible. It makes for better images, faster images, more secure images, and just easier images to manage. When you have fewer packages, fewer things that don't need to be there, your life is a lot easier. And then as well as using Wolfi. This was one of our biggest takeaways. It's great for not only debugging, but also using as a great base image for multi-stage builds for that final stage. And it can, just by nature of being a 0 CVE minimal image, it can limit your vulnerabilities and will give you a good secure base that you bring your packages as you go, bring what you need, start small, and go from there.
Yeah, I guess it kind of seemed like we're ChainGuard salesmen up here, but definitely didn't want to make it seem that way. I think the biggest takeaway is there's more than just using particular debugging tools to debug your environment, right? And so looking at it from 40,000-foot view or the entire landscape as a whole, minimizing the footprint and using the right tools, using the right security parameters, minimizing all the noise, all these things are taken into account, not just the debugging tools. So.
Yeah. And on that note, we're here to answer questions for the next, how many minutes? For the next 3 minutes. So yeah, but you can also find us online at the links provided.
Thank you very much. Questions? Who has questions? Okay, I fly.
Hi, thank you for the talk. My question is more like, is there something beyond using minimal images? Is there some maybe tools or practices, maybe even on organizational or management level, which can help people deal with this whole problem of developers just want to ship their software, right? I don't want to deal with vulnerabilities. I want my change to be in production, right? And then there's security people who say, well, we need compliance, we need to not have vulnerabilities and so on. Is there some maybe other tools or tricks to do maybe on the human level or something like that?
Yeah, I would say the most common is things that will kind of simulate the production environment but bring it local. So we've seen tools like MirrorD or telepresence to provide that ability for the developer to do their job and to properly debug locally, but simulates that production environment. So in addition to using minimal images and trying to slim down your images, not only for the footprint and also for the vulnerabilities, but it's I think a best of both worlds, because you're taking everything down from your cloud environment, wherever your app exists, and you're kind of simulating that for your developers to do, like you said, just what they want to do is they want to work on the application. But you have anything to add to that? Or?
It's a great question. Yeah, I'm thinking other tools that could be beneficial to developers. Maybe Dive for getting high-level insights into what's in your image and what matters without going through the fatigue and overhead of
yeah, so Dive is a good inspection tool for images. as you alluded to, developers don't really care. They just want to use the tools that they're familiar with or the tools that'll get the job done to build their application. But I guess it's always good to be aware of, and just from the administrator side, I guess, always, allowing your developers or giving your developers the proper tools that they need, but also, I feel like there's a balance that you have to strike there between, using whatever tools you want to use versus, or whatever environments you want to use, and also keeping the environment secure.
What were the first two tools that you mentioned besides Dive?
So Mirror and telepresence.
Just repeat for the recording.
What were the first two tools that you mentioned besides Dive?
Yeah, so Mirror and telepresence. Take your environment, kind of simulate that environment to your local workstation, so you can simulate, properly debug, simulate some of the things that you would see in production.
Any more questions? Then I would say thank you for joining and thank you for speaking.
Thank you.
Thank you all.